Hey y'all, Data Guy here, back from my semi-planned holiday hiatus. I hope you all had a great holidays, whatever you're celebrating with your families. I know I did. I'm back refreshed and ready to go. And today, what I have for you, my first video back, is going to be just explaining, what is data mesh architecture? What is a data mesh? Why is it becoming such a common topic, around data engineering teams, organizations? Everyone's trying to get to this almost mythical data mesh architecture. But at the end of the day, it's kind of a hard thing to define. Data mesh can be many different things for different companies, but there are some core principles like these ones up here. I kind of have this simple graphic to get us started that will encompass any common data mesh architecture. And if you like these videos, please like and subscribe. Helps me out an absolute ton. And without further ado, let's get into it. So to explain data mesh at a high level, you have almost like a superhero team where each member or data source has unique powers, capabilities, and they work independently, but as part of a larger kind of organization towards a common goal. And while that might seem kind of a little fluffy, essentially what it is instead of, you having different categories, different big silos saying, hey, I'm going to have all of my ETL processes run in this certain way. They're going to run on this tool. And they're all going to be, very tightly bound together because they're all doing ETL jobs. In a data mesh architecture, you would break that out across possibly many different systems, but you, instead of having to group all of your ETL jobs in that one bucket, you have each ETL job live where it's most effective, where it's actually driving the most value, and totally decentralize where all of your data lives and flows through. Obviously, this requires a lot of organizational capabilities, because if you break out all of your different jobs into kind of just microservices almost, this kind of does work in tandem with a microservice style architecture. But really just having many different pipelines, each laser focused on their specific action without trying to crib in like, oh, well, I want to throw this thing as well. No, each data mesh pipeline, they are defined to perform one certain action rather than just being grouped into large buckets. And so the end state of this that everyone's striving for is a world where data is no longer hoarded in silos. It's accessible, understandable, and actionable across different departments. The marketing team manages their own or has access to their own marketing ETL tools. They don't have to go to a central data engineering team to actually access those. They are self-managing. Obviously, your data engineering team will set these up, but your marketing team will actually own these pipelines. And so kind of just some key points, and this is kind of coming back to this graphic, is you have decentralized data ownership and architecture, you have domain-oriented data as a product, and you have self-serve data architecture, where if I want a new data pipeline, I, as someone who might not be that technical, have the tools to create it. And so here we have kind of a more specific example of what this would look like, because I want to illustrate the point of, hey, in a typical previous architecture where you have, one silo tool that's doing all the ETL jobs for all of these 4 products, you have your data engineering team is managing that. Instead, in a data mesh architecture, each of these products has their own dedicated ETL pipeline. They're managed by the engineering team that is managed for that particular product. And each team that's working on each of these products is self-managing these tools. They're able to self-serve, create new pipelines. If, let's say the team on product 1 in this example, needs to add an additional ETL pipeline, they're able to do that. They don't just have to confine to, hey, each of the products has 2 ETL pipelines and you can't create any more. And that is the data mesh promise. You have full ownership, you have full capability to add new data sets, add new ETL pipelines as your business requires it. Now that you kind of have a high-level view of, what a data mesh architecture is, I want to talk about, some of the advantages and why some people are like really excited about being able to implement data mesh architecture in their own organization. And number one is just enhanced data ownership and quality. Imagine, each department in your organization is the master of its own data domain. And by having this autonomy, by saying, hey, this team that's managing product 1, you can create as many pipelines as you need to do whatever operations you need in product 1. That gives them much higher quality data that lets them access whatever data points they need instead of having to fit into a one-size-fits-all structure for extracting data from their specific application. And it also allows them to customize these pipelines for that specific application because, hey, no one's going to know what data needs to come out of that product except for the people that are managing and using it daily, right? Additionally, by breaking out of this big monolithic state where your data engineer, you have to go talk to your data engineering team every time you want a new pipeline. A data mesh architecture turns your organization into really a data nimble ninja. Adapting, responding to any changes very rapidly because each team is able to say, hey, oh, I need this new data point, let me add it, and I have the tools to do so myself. And then third, you have scalability. As you add new teams in a data mesh architecture, they're able to, your new team is also responsible for adding their new pipelines. And so you think of it almost like a well-planned city where you're able to accommodate the growth seamlessly without saying, hey, every time I want to add a new product, my data engineering team has to go in and, spin up all this extra work. No, the team that's managing that product, they're the ones that are responsible for that. They're the ones that are going to be able to do it most efficiently. So why not give them the full power to do so? And then fourth, you have democratization of data. In a lot of organizations, you have a data engineering team as a service. And so every time you want a new data point, you got to talk to your data engineering team. That adds into the backlog. It's going to be months, maybe years before you actually get it. But in a data mesh architecture, because you have the tools to create these pipelines yourself, you can do so. You don't have to go request it from the data engineering team. You can just start building it yourself and get off the races, right? Get exactly the data points you want because you're the one that's building it. So it's your fault if you don't. Now, every superhero has its kryptonite, and data mesh is no exception. So it's not all just sunshine and rainbows. There are some drawbacks to utilizing this approach. And number one, and that's why I kind of wanted to bring up an example architecture, which you see here of what data mesh could look like, is that you're assembling a 1,000-piece puzzle. It requires a lot of effort and expertise that needs to be distributed amongst all of your teams. You need to make sure your teams are enabled so that they can create their own data pipelines. You need to make sure they have those proper skills or have tooling that allows them to create their own pipelines without necessarily needing to know all this. Maybe you have a system that abstracts away a lot of this back-end action and they just fill in some parameters and it creates a pipeline for them. And so whatever way you approach, whether it's distributing talent or setting up that kind of self-serve operation, it requires a ton of effort and expertise to set up and maintain. And in kind of tandem with that, my second point is that it requires a cultural shift. Many organizations are used to saying, hey, if I'm the marketing team, I'm not touching my own data pipelines. That's something I talk to my data engineering team, they figure it out, or my data analytics team, and I get the results. I don't actually build my own pipelines. With the data mesh architecture, you really need to change that mindset and convince everyone to speak that new language of complete ownership of their data, complete ownership of everything that they're working on, and not only don't emphasize the drawbacks obviously, but the advantages that can bring. They don't no longer have to be frustrated waiting along for the data team to get around to their backlog, right? And then finally, data governance issues. Because you have such a distributed nature of many different pipelines running in many different locations potentially, you need to have a proper governance system to understand, hey, who's changing what data, who's changing, different pipelines. Because if you have many different teams, someone could screw up a data source that other teams are relying on and not know that they're relying on it because they're managing their own application over there. This guy's managing his own application here, but they have that common data set. And if one person screws that up, then it can affect the other team's downstream pipelines, but they won't really have a clear understanding of what happened there because maybe they're not talking to that other team for whatever reason. So now you know some of the advantages, some of the disadvantages. I kind of want to tie that all together with the point of data mesh isn't a one-size-fits-all solution. It's not going to be perfect for every organization. It is really like a kind of a tailored suit. It's perfect for specific scenarios, but it's not going to be right for every company. And so here I kind of just have an example of what a Cloudera, their unified data fabric, which is essentially just a data mesh, but Cloudera has their own name for it for whatever reason. And so the reason why I showed this is because data meshes are really useful for large, complex organizations. If you already have a sprawling metropolis of data where you have data teams that's overloaded, having to serve tons of different teams, tons of different data sources, data mesh can help you manage this complexity efficiently by kind of distributing that cognitive load across each individual team rather than centralizing it within that data engineering team. And then kind of in tandem with this, and this is why I chose Cloudera as an example, is organizations where you have a ton of different diverse data sources, where you have proprietary data, machine data, advertising data, customer data, all coming together. Data mesh can be that skilled juggler that's keeping everything in harmony. It's able to adapt to all these different use cases and have them all kind of fit together and play nicely in the same sandbox. And then it also enables a more agile and fast-paced environment where you can quickly add additional data pipelines, add new insights as you need them, rather than again needing to wait on a centralized organization to create them for you. And then finally, and the reason why I chose this graphic is I want to talk about what tools you'll need for your data mesh adventure. And so here you can see a few of them examples, that we have Cloudera using here. But you're going to need a couple different things. You're going to need data catalogs, tools like Calibra, like Alation, that are going to be your data GPS, helping you understand your data landscape, keeping track of where each piece of data is, who controls it, et cetera, et cetera. You're going to need data integration, pipeline tools, something like Airflow maybe. Airflow is actually really good for data mesh architecture, and I've seen a lot of people use Airflow to implement it because it can adapt to all those many different use cases. You can add new pipelines very quickly by creating templates for them, and so having a system that, or a pipeline tool like Airflow, maybe if you want to use streaming, use Kafka. They're able to power all the many different data pipelines that you then have to manage as you break out of those silos. You also are going to need tools like Datadog, Great Expectations to just make sure your data quality stays up to a certain standard, governance isn't compromised, and just have those systems in place to manage all this complexity. And then finally, something like a Databricks, like a Snowflake, allowing or a BigQuery, where you're allowing users to kind of come in and, or Tableau, run analytics on this data, give them tools to actually visualize the insights that they're gathering from all of these different pipelines. So in conclusion, what I want to leave you with is, data mesh is really a exciting and complex approach to managing data in large organizations. It's like building a new city. It's challenging, but it's very rewarding when you're done it right. And with the right mindset and tools and also the right use cases, data mesh can really transform your data landscape. So hope you found some insights from this video, and good luck meshing up your data. Have a good one. Data Guy out.